Okay. Good morning, students. So today we will discuss about the law of chemical combinations. There are some four important laws. Today just will study about the law of chemical combinations. We go for the first law. So the law of conservation of mass. First law. The law of conservation of mass. The law of conservation of mass, right? So before just explaining the law, just I will give one example. So here in terms of here, so this is an HgO, that is mercuric oxide. This compound we are called mercuric oxide, HgO. This mercuric oxide that will be decomposed to give mercury plus and oxygen. Mercury plus oxygen, right? Still this is not at balance, so we have to be balance the oxygen, balance the reaction. So balance ಹೇಗೆ ಮಾಡಬೇಕಂತ ಹೇಳಿದ್ರೆ, so this arrow mark this side we are called product and arrow mark this side we are called reactant. This is an reactant and this is the product, right? So the number of atoms in the product size that has been equals to the number of reactants in the reactant side. Reactants are less atoms ಇರುತ್ತಲ್ಲ, product side ಅಲ್ಲೂ ಅಷ್ಟೇ atom ಇರಬೇಕು. If we go for oxygen atom, there have been the two oxygen atoms, right? So ಇಲ್ಲಿಗೆ ಬಂದಾಗ ಏನಾಗುತ್ತೆ, there is only one oxygen atom. So that's why to make it balance we have been write the two, right? So now here there have been the two mercury atoms, here it is only one mercury atom, so that's why we have been make it two. So now this is balance. So this mercuric oxide that will be decomposed to give mercury and oxygen. Understood? So the mass of this is nothing but the 10 grams. The mass of it is about 10 grams. Illige bandaga enagutte, so after decomposition it will be give 9.5 grams, right? 9.5 grams, and this is nothing but in terms of here 0.5 grams. 0.5 grams, right? So in terms of here the mass of the sum of mass of product, the sum means combine these two, the mercury and oxygen, the sum of the mass of product is found to be same as sum of mass of reactants. So that is nothing but the law of conservation of mass, right? So law of conservation of mass anta bandaga enagutte, so the mass is neither be created or nor be destroyed in a chemical reaction, right? So the mass is neither be created nor be destroyed in a chemical reaction. That is the law of conservation of mass, right? That can in terms of here, so this is the 10 grams after decomposition, so we are getting 9.5 grams and 0.5 grams. If we combine these two, 9.5 and 0.5, again we have been getting the 10 grams only, right? That's why so the mass is neither be created, right, nor be destroyed. Illi decompose ಆದಾಗ ಏನಾಗುತ್ತೆ, mass ಕಡಿಮೆನೂ ಆಗಲಿಲ್ಲ, mass ಜಾಸ್ತಿನೂ ಆಗಲಿಲ್ಲ, right? So that is nothing but the first law, the law of conservation of mass. The mass is neither be created or nor be destroyed in a chemical reaction. So that is nothing but the first law. Come for the second law. So the law of definite proportion. The law of definite proportion. So here in this the law of definite proportions, I will give an example. So the carbon, here we are getting the carbon dioxide, right? So how can we prepare the synthesis the carbon dioxide gas? So just by the combination, how will you get the carbon dioxide gas? Just by the combination of carbon and oxygen, right? So this carbon, if will be burn this wood, if will burn the paper, if will be burn the cloth, we are getting the carbon dioxide gas. Understood? If you burn the paper, we are getting carbon dioxide gas. If you burn the wood, we are getting the carbon dioxide gas. If you burn the cloth, we are getting carbon dioxide gas. So in terms of this carbon, it will be burned with the oxygen. In the presence of oxygen, we are getting carbon dioxide gas, right? So I will get the carbon dioxide gas in terms of here from the heating of calcium carbonate or limestone, CaCO3. This CaCO3 that will get decomposed to give calcium oxide plus carbon dioxide gas, right? So calcium oxide plus the carbon dioxide gas. Now this carbon dioxide gas and this carbon dioxide gas, so in terms of the definite ratio, Here also, here we are getting the carbon dioxide gas just by the combination of carbon and oxygen. Here this carbon, we are getting the carbon dioxide gas from the decomposition of calcium carbonate or limestone. This is also been called limestone, sunna, right? So this carbon dioxide gas and this carbon dioxide has been same, right? Here this one also been containing one carbon, the two oxygen and the two oxygen atom, right? So the law of definite proportions are nothing but, in terms of here, the chemical compound always contains the same element. Chemical compounds always contain the same element combined in the same proportions by mass, right? So that one we are called the law of definite proportions, right? The chemical compound always contain the same element, right? So the chemical compound always contains the same element combined in the same proportions by mass, combined in the same proportion by mass. That one we are called, so the law of definite proportions. For I will give one more example in terms of here. So this water molecule, if we go for water molecule, this water molecule, so we have been getting from the river, we have been getting from the well, we have been getting from the sea, right? So ಯಾವುದೇ water ತಗೊಳ್ಳಿ, so if you can take any water, right? So you can take water from the well, sea, river, right, lakes, whatever it may be the water. So the pure water, it always contains the two hydrogen atom and one oxygen atom, the two hydrogen atoms and one oxygen atom. So that one we are called law of definite proportions. The chemical compound always contains the same element combined in the same proportion by mass, combined in the same proportion by mass is called law of definite proportions, right? So come for the third law, the law of multiple proportions. Third law, the law of multiple proportions. The law of multiple proportions. I will give an example here. In this one, hydrogen reacts with oxygen atom. Hydrogen reacts with oxygen atom. It will be give the water molecule is a product, H2O is the product. If we go for mass, obviously the atomic mass of hydrogen is 1. For one hydrogen atom, there have been the 2 hydrogen atom, that's mass is 2 grams. Here it is about mass of oxygen atom is 16 grams. If we combine these two, obviously it is 18 grams. 18 grams, right? So here, if we come for here, hydrogen and oxygen molecule, it will be gives rise to an H2O2. Here it is about the 2 grams. Here about there have been the 2 oxygen atoms, that is and 32 grams, right? So it will be gives rise to, in terms of the 34 grams. 34 grams, right? So if it will become go for here, if it will be observed properly here, so here also hydrogen atom, here also hydrogen atom, right? So here also the same molecule, oxygen atom, here oxygen molecule. Here it is an oxygen atom, here oxygen the molecule, 16 grams and 32 grams, right? So but we have been getting the product has been different, the water has been different from hydrogen peroxide. This is water, H2O is a water, you people already know, ನಿಮಗೆ ಗೊತ್ತಿದೆ H2O ಅಂದ್ರೆ ವಾಟರ್ ಅಂತ. ಇದೇನಾಗುತ್ತೆ ಹೈಡ್ರೋಜನ್ ಪೆರಾಕ್ಸೈಡ್ H2O2. ಒಂದು ಆಕ್ಸಿಜನ್ ಆಟಮ್ ಜಾಸ್ತಿ ಆಯಿತು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಸೊ ದಟ್ ಈಸ್ ಹೈಡ್ರೋಜನ್ ದ ಪೆರಾಕ್ಸೈಡ್ ಆಗುತ್ತೆ, ರೈಟ್? The two elements combine to form more than one compound. The two elements, for example, these have been the two elements, right? The two elements combine to form more than one compound. The mass of one element is fixed. The mass of one element is fixed with the other elements. That one we are called law of multiple proportions. What do you mean by law of multiple proportions? When the two elements of different atoms combines to form more than one compound. When the two elements combine to form more than one compound, these have been the two elements, right? Hydrogen and oxygen combine to form the two different compounds. Water is also been compound, hydrogen peroxide is also been compound, right? The one atom of the one element that has been fixed with the other element, this hydrogen has been fixed here, the 2 grams and 2 grams with the oxygen. That one we are called the law of multiple proportions. Come for the fourth law, that's the last law, the Avogadro law. Avogadro's law, right? So here Avogadro's law, just I will give an example. Here in this one, just I will take a volume of about 1 liter. Volume of 1 liter, right? So here in this 1 liter, if I will be fill hydrogen gas, I will take one more container. So here in this, again the same, the 1 liter, right? So here if I will be fill carbon dioxide gas, again I will take 1 liter. I will be fill ammonia gas. Again I will take 1 liter volume. So here in this one also, I will fill methane gas, CH4. So here the number of molecules that has been filled in the hydrogen is same as the number of molecules of carbon dioxide is same as number of molecules of methane. For example, if 100 molecules have been filled hydrogen gas, 100 molecules of carbon dioxide gas has been filled, 100 molecules of methane gas has been filled. So if the volume is same, the same 100 molecules of ammonia gas also been filled, right? So that one we are called Avogadro's law. All gases containing equal number of molecules under similar condition of temperature and pressure, that one we are called Avogadro's law. Understood? So if we go for 2 liters, obviously 2 liters ಏನಾಗುತ್ತೆ, the 200 molecules of hydrogen, 200 molecules of carbon dioxide, 200 molecules of methane. Understood? Right? So if hydrogen mass is different from carbon dioxide mass is different from methane mass is different from ammonia, right? Number of molecules that will be not change. Equal. So all gases contain equal number of molecules. All gases contain equal number of molecules under similar condition of temperature and pressure. That one we are called an Avogadro's law. Understood? These have been nothing but the 4 important, the law of chemicals, right? So we go for next one. So that is Dalton's atomic theory, right? It's been very important one, Dalton's atomic theory. Dalton's atomic theory. Dalton's atomic theory. Just he'll telling about the postulates of an atom, right? So he has been proposed first, the John Dalton, the first person that has been so telling about the atomic theory, right? So postulates of an atom. So there are some important postulates are there. Just listen properly. In that the first postulate is nothing but matter is made up of and small particles called atom. You can take any matter. The matter is made up of and small particles called an atom. For example, this is also been a matter, right? So if it will be breakdown, right? So it break marta hodag enagutte. So finally enagutte, we have been getting one particle that cannot be break, right? So that particle we are called atom. So that can be explained by Dalton's atomic theory. Understood? Right? The matter is made up of the small particles called an atom. Right? So that's the first one. That's the first postulates. Come for the second postulates. Right? Atom of same element. The atom of same element, right, exhibit the similar properties. For example, if we go for hydrogen one atom, I will be consider one more hydrogen, right? So the in terms of it will be exhibit the similar property, right? So this is also been an atom, this is also been an atom, right? So this size, the size of both the atoms same, the size of hydrogen and size of this hydrogen remain same, right? The size, the shape, right? The size, shape, and then in terms of here the mass and properties, right? So remains same of same elements, right? Atom of same element exhibit its similar properties. The atom of similar element exhibit its similar properties like size, shape, mass and properties. Understood? So come for the third one. So the third one ಬಂದಾಗ ಏನಾಗುತ್ತೆ, so the atom of different elements exhibit different properties, like, so for example, if we go for here the hydrogen and oxygen, right? The size of hydrogen has been different from size of oxygen. The shape of hydrogen is different from shape of oxygen. The mass of hydrogen is different from mass of oxygen. The property of hydrogen is different from property of oxygen atom, right? So in terms of here, the atom of different element exhibits its different properties, like size, shape, mass and property. It will exhibit different property, right? So that's the third one. Come for the fourth one, right? So the atom is neither be created or nor be destroyed in a chemical reaction. The atom is neither be created, right? It cannot be created, and it cannot be destroyed in a chemical reaction, but just it can transfer from one form to another form, right? Atom is neither be created or nor be destroyed in a chemical reaction. That's the fourth one, right? So come for the fifth one. ಬಂದಾಗ ಏನಾಗುತ್ತೆ, the compound, right? So the compound is formed by the combination of two or more different atoms. For example, so the CH4, methane, is a compound. It is combined by the combination of carbon and hydrogen, right? So the water is a compound. It is formed by the combination of hydrogen and oxygen. So the carbon dioxide is a compound. It is formed by the combination of carbon and oxygen, right? So the compound is one, so which is formed by the combination of two or more different atoms, right? And the sixth one, atom is the smallest particle that will be take part in a chemical reaction. Atom is the smallest particle that will be take part in the chemical reactions. So these have been nothing but the postulates of Dalton's atomic theory. These have been the postulates of Dalton's atomic theory. They have have some drawbacks, right? So drawbacks ಏನಪ್ಪಾ ಅಂತ ಹೇಳಿದಾಗ ಏನಾಗುತ್ತೆ, so the it doesn't explain how the molecules get combined, right? So what is the force, what is the interactive force, right? So how is there any force or is there any bond, that will be not explained by this Dalton, right? So ಎರಡು ಮಾಲಿಕ್ಯೂಲ್ ಮಧ್ಯೆ ಏನಾಗುತ್ತೆ, ಯಾವ್ದು ಅಟ್ರಾಕ್ಷನ್ ಇದೆ, ಯಾವ್ದು ಇಂಟ್ರಾಕ್ಷನ್ ಇದೆ, ಯಾವ ಬಾಂಡ್ ಇದೆ, that is not explained by this Dalton. That's the first drawback, right? So it doesn't explain how the compound get formed. It does not explain the compound ಹೆಂಗ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿಲ್ಲ, right? So how this carbon and hydrogen get combined, how the hydrogen and oxygen get combined, how the carbon and oxygen get combined to form compounds. That is nothing but so the drawbacks of Dalton's atomic theory, right? So now we go for one more, just I will give one formula, right? So where we can how to be convert in terms of the degree into Fahrenheits, right? So for example, in terms of here, that is an degree. So here in this one, so that is an 5/9 into, so that is an F minus 32, right? So this is the formula where we can convert, so in terms of here, the degree into Fahrenheits, right? So Fahrenheits into degree ಅಂತ ಹೇಳಿದಾಗ ಏನಾಗುತ್ತೆ, so that is in terms of here, F equals, so that is a 9/5 C plus 32, right? So this is the formula where we can easily convert, so degree into Fahrenheits and Fahrenheits into the degree, right? So this is about your, so the temperature, right? So this is about your temperature, understood? And also the main important thing is nothing but how to be convert the degree into Kelvin, right? So degree which has been equals to, so in terms of here, temperature which has been equals to degree plus 273, right? So if we'll be add this one, it will be converted into Kelvin. For example, 27 degree Celsius ಅಂತ ಇದೆ ಅಂತ ಹೇಳ್ಕೊಳ್ಳಿ, 27 degree Celsius ಇದೆ, 27 degree Celsius ಗೆ I have to be converted into Kelvin convert ಮಾಡಬೇಕು, right? Just by the addition of 273. So that is 27 plus and 273 ಅವಾಗ ಏನಾಗುತ್ತೆ, here it is 0, here it is 300 Kelvin, right? So 300 Kelvin ಆಗುತ್ತೆ, understood, right? So this is how we can convert the degree into Kelvin. It has been very helpful for to solve the problems. And about, if it become for about the pressure, It will become about the pressure where 1 atmospheric pressure equals 760 millimeter of mercury. 760 millimeter of mercury. 1 atmosphere which is equals to 760 millimeter of mercury. Right. So which has been equals to 760 torr. 760 torr which has been equals to, that is 101.3 Pascal. ರೈಟ್. ಸೊ ನಿಮಗೆ ಗೊತ್ತಿದೆ 1 kg ಅಂದರೆ ಏನಾಗುತ್ತೆ, 1000 grams ಆಗುತ್ತಾ? ಎರಡು ಈಕ್ವಲ್ ತಾನೆ, 1000 grams ಅಂದರೂ ಅದು ಒಂದೇ, 1 kg ಅಂದರೂ ಒಂದೇ. ಹಿಯರ್ ಆಲ್ಸೋ ಸೇಮ್ ಥಿಂಗ್, ರೈಟ್. ಸೊ ಪ್ರೆಷರಿಗೆ ಬಂದಾಗ ಏನಾಗುತ್ತೆ, ಸೊ 1 atmosphere ದಟ್ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು 760 millimeter of mercury which has been equals to 760 torr which has been equals to 101.3 Pascal. Understood? Right. Thank you.